Today I'll be talking about recent advances in the understanding of cancer stem cells and treatments targeting them. So originally, what are cancer stem cells? Well, we have to go over that first. So the model you see on the right there is called the stochastic tumor growth model. And so basically that's what we thought cancer used to grow like. So we just had the one cell at the top, the orange one, and we would just divide indefinitely, creating a bunch of equal cells that were ranked equally. And now with the new understanding and research that's been done, we understand that the model on the left, the here called tumor growth cell model, is more accurate. And so in this model, what we have is the orange cell at the top, the cancer stem cell. What it does is it divides asymmetrically. And so it divides into, on the left, the green cell, which is which becomes a stochastic tumor growth cell. And that's the model that follows. And then on the other side, it turns into another cancer stem cell. And while it's doing all of this, it not only does it asymmetrically reproduce, meaning it keeps a constant number of cancer stem cells at all times, but also it divides slowly. And so what that means is that it's able to avoid standard therapy by dividing slowly, since common therapies usually target fast or dividing cancer stem cells, and that's also why it affects things like bone marrow cells and hair cells. So as you can see here, if we use standard therapy, the tumor bulk or the majority of cancer stem cells will be effectively killed. However, after a while, the cancer stem cells are able to regenerate the entire cancer as they survived, and that eventually leads to tumor relapse. However, on the other hand, if we target cancer stem cells and take them out first, then we can use standard therapy afterward, and the tumor bulk will eventually be defeated and eradicated, since there's no seed in order to regenerate the entire cancer. So next, we need to talk about ways to target cancer stem cells, and one particular method of doing that is by using biomarkers. So cancer stem cells have a lot of biomarkers in common with other cancer cells or non-cancerous counterparts, and that means that they're difficult to target and specifically go after. However, there have been many cancer stem cell biomarkers that have been identified as possible ways to target them, and that they've been showing a lot of promise. Other biomarkers have also been identified as early warnings of aggressive cancers, and that allows them to prepare for the worst, as they know that the cancer is most likely going to be aggressive. And so these are just some current studies that identify target cancer stem cells. There's two of them I want to talk about with you guys in particular, and that would be the fourth and fifth one. And so what they have is in common is dendritic cells. And so basically what these cells do is that they're able to target cancer stem cells on their own without humans actually needing to identify which biomarker specifically they want to use. And in order to do that, what they do is they put some mRNA with the dendritic cells, and then that allows them to find their own biomarkers. And then once they go into a vaccine, then they can target cancer stem cells. And some of the other biomarkers that have been used are CD26. We've also used 7 miRNAs/10 mRNAs, and also S1P, and there are many others. So in conclusion, we've had a lot of different types of studies on cancer stem cells. First, they discovered that cancer stem cells are associated with the recurrence of cancers once they were considered cured. And currently, there's no perfect method to target all cancer stem cells. However, there's been a lot of biomarkers that have shown potential in the ability to target cancer stem cells, and other dendritic cells also don't even require biomarkers to be identified, and are another method that can be used to target cancer stem cells. And so future research should also focus on finding biomarkers that are responsible for cancer stem cells' ability to divide slowly and their ability to divide asymmetrically, as it's a trait that's unique to cancer stem cells that other cancer cells do not have. And that's it.
Great job, Partha. You want to turn off your presentation and share your experience about the program?
Yeah. So the one thing I really liked about this program was the couple of weeks at the beginning where we got to learn about different cancer, about just the body in general first. And then we learned about cancer and we learned a bunch of new different topics. And that really helped shape the direction that I wanted to go in for this research project. And it really helped my overall understanding of like the body. And I just think that was very helpful for me in this research project. It also gave me like ideas on what to write for my paper.
Excellent. Excellent job, Partha. It was a really, really good in-depth research and presentation. Prahalad, question for him.
Hi, great job, Partha. Great presentation. So in your opinion, so you think there are stem cells in each organ also, right? Yeah. So the biomarkers that are identified with cancer stem cell, so are they able to distinguish from the normal stem cells?
Yes, there's actually studies on this. Like some of the studies I was looking at, while they do have a lot of overlapping biomarkers, some of them aren't in common. So in fact, even within cancer stem cells of the same type, they have different biomarkers. And when cancer stem cells undergo their mutation, they do change what biomarkers they have on them.
Excellent. Yeah. Great job. Congratulations.
Thank you.